How's this? Welcome to Module 2, Difference in Difference. We will be going over our lecture today, reviewing the lab and doing a mock-up version of the lab in order to help demonstrate how you guys should go about um, doing the lab. So welcome, thanks for being here. As a preface, as always, if you get caught up in the lab, I always recommend that you circle back to the lecture. These modules are set up in a very effective way where it shows you seamlessly within the lecture how to complete the lab. In addition to that, we'll have the code through that I'll do at the end of this video. But again, always circle back to the lab or the lecture, pardon me, if you get stuck in the lab. Pretty much all the answers are in the lecture, at least to show you how to do it. Okay. Oh, and excuse me. Second thing, as always, if you have a issue, question, errors you're running into, make sure that you post on the issue tracker, and I will get back to you as soon as I can. With that, one final note: do not wait until Thursday or Friday in order to start to work on your lab. If you run into issues Thursday or Friday, if you wait to the last minute and you post your issues on the issue tracker, if it's Thursday or Friday, I may very well not see it in time for you to turn in your lab on time. So don't procrastinate. Make sure you get a head start on this. Let's get into it. So difference in difference will be a little different than our interrupted time series last week. Last week pardon me, the biggest difference with difference in difference is we will be using requires a treatment and a control group. For those of you that pursued the bonus question last week in the interrupted time series lab, it was an opportunity to run through what an interrupted time series would look like with a comparison group. For difference in difference, we need a comparison group. So we will have our control group and our treatment group. And ultimately, it's in the name. Difference in difference is going to be looking at both within group change and between group change. So you're going to be using a treatment group which underwent some kind of a treatment or policy intervention, and use that against the control group which did not undergo that. Now, very important, we will always be looking at the average outcome. And keep this in mind as we go into the summary table shortly. The coefficients, as you interpret them, they're additive in nature, and it'll make more sense here shortly. But as a comparison or as an example, we have our pre-treatment control group average, our post-treatment, let's say our treatment is right here. We have our post-treatment control group average, pre-treatment treatment group average, post-treatment treatment group average, and we're looking at the difference. Difference in difference is ultimately the difference between the pre and post within group, and then the difference between treatment group and control group, or that value of the difference. So to see it as a formula, within your treatment group, you have your post-treatment period average, your pre-treatment period average, and you want the difference. And then you want the same for your control group. In this situation here, that gives us a value of 15. We call this the diff and diff estimate, or it can also be called the diff and diff estimator. And that ultimately tells us if it is different from 0, our treatment had an effect, some effect. So keep that in mind. Now, this is all going to be working with grouped data, and we're going to be comparing between the groups as we mentioned. And as I mentioned before, the coefficients, they're going to be representing the difference, kind of like the last week for interrupted time series. It didn't represent the value of the slope in and of itself. It represented the change in the slope. Well, similarly, the values we look at in our coefficient table, it's going to be the difference between different points in time between in the group, the treatment group, or control group. Blabbering, let's move on. The statistical model is going to look something like this. You have your treatment, which represents, it's actually more of a group indicator. It's going to indicate whether it's the treatment group or the control group, so toggled on or off depending. So here we have our treatment group. You can tell that because the treatment is indicated as on. So this is our treatment group. They underwent the treatment. And where it is 0, this is our control group. So that's our first variable here. Our post is going to be representing our prior to intervention time period and our post intervention time period. So you'll see here of the 4 different subjects, 8 observations. For each subject, we have 1 pre-intervention measurement or observation. And then for every subject, we have a single post-treatment observation. So this is going to be representing our before and after treatment. And then this is the first time I believe, yeah, we have an interaction term. So the interaction term is simply the way that within our model, we can account for the treatment group's post-treatment value. As you'll see here, it's very simple. 1 times 1 equals 1. So if the treatment is toggled on, if the post-treatment is toggled on, then our treatment times post is on. You'll see that in the control group, not a single post-treatment or treatment post interaction term is on, and that's because it is either 1 or 0, not 1 and 1. Okay, so let's move into the coefficients. Coefficients in our circumstances here are going to be a bit unique. They're additive in nature, as I mentioned. So what we'll have is first beta 0. This is going to represent the control group, or C1, we'll just call it, because I believe that's how it references it in some of the additional PowerPoint resources you'll have for this week's lab, or this week's module. So it'll represent C1, which is going to be the first point in time for the control group. That's the actual value, and we'll see that plotted here. Beta 0 represents the actual average for the control group pre-intervention. Now, the beta 1, excuse me, now this is where we start to represent the difference. So beta 0 represents the actual average value, beta 1 represents the difference. So beta 1 is going to represent the difference between beta 0, and add these together, you'll get the actual pre-intervention treatment group average. So in this example, our pre-intervention for the treatment group has a starting point where the average, whatever we're measuring, is higher. So in order to get that, excuse me, beta 0, add beta 0, beta 1, that gives you your pre-intervention treatment group average. Now, similarly, beta 2 is going to represent the change in our pre-treatment control group average and our post-treatment control group average, as demonstrated here. So in order to get our actual post-treatment control group average, all you want to do is add beta 0 and beta 2, and that'll give you the average. Beta 3 is going to represent our diff and diff estimator. So once again, if beta 3 is 0, then we will conclude that the treatment has no effect. If different from 0, it has some form of an effect. So in order to get our post-treatment treatment group average, we will need our beta 0, which represents our pre-treatment comparison group average. And then we want to add in our pre-treatment treatment group average, as well as the change for the post-treatment treatment group, or the comparison group average, pardon me, getting tongue-tied on all this. And then we want to add in our diff and diff estimate, ultimately showing what the average for our post-treatment treatment group would be. Now, this beta 3, this is our diff and diff estimator. This also represents the counterfactual. So I'm going to skip this and come right back to it. So the counterfactual is also going to be where would our result be had the intervention never occurred? And you'll see visually, and we'll talk about this at the end, a diff and diff requires a assumption, parallel lines assumption. And that's demonstrated here without directly talking about it, where we are simply assuming that the differences between our control and our treatment group would not be so much that their trend would differ, having no treatment occur. So this is a huge part of a diff and diff model, is that we will be assuming that the lines would be parallel if the treatment doesn't occur. So with that being said, our counterfactual is going to be represented by where our baseline for our treatment group started before intervention on the same trend. Where would it be at the second point in time we collect observations? So really, you'll see the beta 3, which was 15, is simply the difference between our counterfactual and what our treatment post-treatment group average was. Post-intervention treatment group average was. My goodness, I'll get it one of these days. And you can see that here calculated. This visualization is great. You'll want to come back to this because it captures the values that you'll need to calculate and determine in your lab. Going into an example, and this is the only example we're going to cover in this lecture. The second example in here, the replication of a study section, I'm going to leave that to you to go through. Fairly straightforward, but we will cover this. So for this example, we're simply looking at subsidized housing projects. So subsidized housing projects, and in that discussion, that realm of subsidized housing projects, you have critics that say living near affordable housing or subsidized housing leads to a decline in the housing value of nearby neighborhoods. So what we're going to do in this example is we're going to use a diff and diff model to test if that is the case. So our hypothesis is that housing projects reduce housing value. So if you have a home near housing projects, your home will be worth less than homes not near housing projects. And that's captured once again here. So we will have a treatment group, which our treatment group will consist of um, homes that are near subsidized housing projects, and our control group, which will be homes that are far away from subsidized housing sites. Here's what our data looks like. Straightforward. You have your housing prices. You have your group indicator. So your treatment group indicator, this is saying 0 for control group, 1 for treatment, and then post-treatment indicating whether the observation is after the treatment occurred or prior to. So we'll have 1 for each observation. And you won't have to do the wrangling that you did in last week's lab. The only thing you'll need to do is include an interaction term, if I'm not mistaken, where you simply are going to be taking the fields that already exist, the columns that already exist, and you're going to be adding this multiplication. So make sure to have an interaction term. So we have our coefficients here. I want you to pause right now. And based on what I already went over with you about what each of these coefficients represent, take your time and determine what you think each of these represent in terms of our housing project. Pause it and we'll get started or come back to it. Okay, I'm assuming you took your time to go through on your own. So let's go through it. Beta 0, as mentioned previously, beta 0 represents the average. I apologize, class. I have a shortcut key on my recording software where when I press space, it actually pauses my video. So I'm going to reset, and this might be a little redundant. What we're going to be doing is looking at discussing what each coefficient means. So I'm unable to type because I have a shortcut of the spacebar. Perhaps I can do it without the spacebar. It is our average. pre-treatment for our control group. This takes some intensive effort to not type space out of habit. So beta 0 will represent the average pre-treatment for our control group. Beta 1 represents the difference between pre-treatment control group and pre-treatment treatment group. Oh boy. Post-treatment, beta 2, this is going to be representative of what our, the difference, excuse me, will be the pre-treatment control group and post-treatment control group. Boy, this gets tough. We're going to do this slightly differently for reference. So we'll call this C1. This is the point in time we have here my own notes. It is 1642. We will be coming back to cut out. uh, so now looking at our coefficients again, I want you to take a moment and try and determine or review with yourself what each of these represent. Okay, I'm assuming you paused and had a moment to discuss that with yourself. So we'll review it once again. Beta 0, this represents our pre-intervention control group average. So I'm just going to call that C1 for our purposes. That's a 1. Nobody say otherwise. Don't judge me here. Now, the treatment group, this is going to represent the difference in our pre-intervention period, the difference between our control group and our treatment group. So once again, even though I'm writing T1 right here, this does not, beta 1 in and of itself, does not represent the pre-treatment treatment group average. This represents the change. So T1 would actually be C1 plus beta 1, or however we want to structure it. Just know that beta 0, beta 1 represent the pre-intervention period, and beta 1 needs to be added to beta 0 in order to create T1. Okay, so make note of that however you wish to. Now, post-treatment, this is going to be post-treatment, this is going to be the change in C1 and C2. So this is time 2. So this after treatment went into place. This is going to tell us the difference between our C1 and what C2 would be. In order to do that, though, once again, C2, even though I'm writing C2 right here, this does not in and of itself represent the post-treatment control group average. Instead, it represents the change in beta 0, which is our control group pre-intervention average. So you'll want to add beta 2 and beta 0. Let's just throw that in there. Beta 0 plus beta 2. And then this again will be beta 0 plus beta 1. And now finally, we have our diff and diff estimator, which is the 34,066, all of which are statistically significant, by the way, and that matters. So the diff and diff represents T2, we'll call it, not in and of itself, but it does require beta 0, beta 1, beta 2, and beta 3. Boy, I hope you folks are nice and not going to give me a bunch of flack about this terrible drawing. So the diff and diff is going to be what's added to in order to show us the end results or the post-treatment treatment group average. Okay, I hope that makes sense for you. If anybody needs clarification, as always, reach out. However, if you just read through this on your own in addition to the video, it will make ample sense. So in the context of our uh, study here, again, looking at housing projects and how they affect housing value, we can see that the baseline for our control group is $216,000, 673 cents. That's our average home price. Now, our treatment group has a baseline housing price that's $16,461 more. Now we can see that the just over time, post-treatment control group, it went up. So the average housing value went up by X number of time. I don't believe we have anything indicating how much time, but it went up by $35,000. So we can say that over time, housing values increase, which of course they do. It makes sense. Now what we can look at here too is that just by being near, actually this is our control group once again, which is nowhere near a subsidized housing project. Our treatment group is near a subsidized housing projects. We can see that it is statistically significant that there is an increase in the housing value just because you're closer to a subsidized housing project. So our hypothesis or our hypothesis here is one, because it actually reported an increase, not a decrease. Now, go through this on your own. You can discuss the results with yourself. Don't jump straight to the answers. Go through, discuss, or determine the results. Think about it. This will also go on to explain a little bit more about how to interpret each of them. What I've given you thus far is the pretty straightforward way to understand what you're looking at, but this goes into actually a spot that I missed. So this section here will circle back to this section. Bear with me here. That discusses how really each coefficient is representing its own hypothesis. So beta zero, this is a hypothesis. It's asking is the average outcome of the control group before the treatment not equal to zero? And then so on and so forth. But this right here will make more sense. Oh, not sure why that's not working. There we go. Um, this will make is more applicable, excuse me, to this section here after we look at the first diff and diff model. Okay, so read through that on your own time. And the counterfactual, this is a great summary page to look at. I believe we already discussed the counterfactual. So the counterfactual is once again represented by beta 3. It's the difference between the post-treatment group average and what would have been had treatment not occurred. And you have the formulas on how to calculate that here. So we can see that if treatment had not occurred, our housing values would be $268,364. But because treatment occurred, subsidized housing projects were built nearby. Uh, the value of our homes more expensive, magnitude of what was it, roughly $36,000. This section, the replication of a study, I'm going to leave this to you. It's a really interesting one. It looks at the common argument you hear if increasing minimum wage reduces employment. So it's one you can go through on your own and take a look at. Now, passing over all of this, we discussed momentarily at the beginning something called the parallel trend assumption. And that is once again assuming that our groups are not so different as to expect different trends or different slopes. So this is an assumption that is built into a different diff and diff because it doesn't work if we're working with different groups. So if you're working with a pause momentarily to find what I was looking for. So the parallel trend assumption again is all about the groups, the difference in the groups. So if the groups are similar, you would expect a similar trend. However, if the groups are different, the trends may be different. And if you use a diff and diff, you may actually determine an overestimate of the effect of treatment. Simply because let's say that the group one in this scenario comes from a family, a wealthier family that has um, um, college educated parents, they are more likely to pursue college, so we can call it college admissions, versus a underprivileged household where parents were not college educated, lower income, they would be less likely to go to college. And so if you were to look at some treatment that was supposed to help increase college admission, if you were to take this assumption or run this model on this situation, you would determine that the treatment was significantly effective. However, when you theoretically look at the difference between the groups, it's fair to say that you can't attribute the success or the effect of the program to the program in entirety. So it becomes difficult because there's not an easy way to test for it. So it's largely based on theory to make the argument, and you have to have the data to be able to compare the trend. But ultimately, you just want to wrap your head around: is there a difference in the groups that would cause one group to have a different trend than the other? You want to have similar groups for this. If the parallel trend assumption um, doesn't fit because our groups are so different and we would expect a non-parallel trend, then the diff and diff may not be the best option. So that's it for going over the lecture. Review all this on your own, and then we will jump into our lab preview and go through an example scenario. Thank you.